So that's its horizontal and vertical components. Now, horizontally, it's not experiencing any force. Okay, it is experiencing a force. In fact, if we replay that, and this time we can add the acceleration components, then if we replay it, you can see there was a force the whole time. If I just put it in slow, there is a downward force, and it's always acting down. And that's because it's gravity. Okay, gravity is always acting down. We're ignoring the curvature of the Earth. So, yeah, exactly. So it's negligible. So the force is always down, and that force is causing an acceleration. So essentially, the acceleration is always down. Okay, so vertically there is an acceleration, but horizontally there isn't. So we know, therefore, the final velocity, which we can see looks like to be something like that. We don't know what the angle is yet, but you may be able to make a prediction. You may have a hunch what the angle is going to be, but we can go about proving it shortly. And so the final velocity, the horizontal component of the final velocity, let's put the final velocity there. The horizontal component of the final velocity is going to be v, and let's call that theta, v cos theta. Okay. Oh, wait a second, what we're talking about. It is v cos theta, but because it's the same as the initial one, that's the same as u cos theta. Okay, so v cos theta is equal to, v cos theta is equal to u cos theta, but I should say u cos 30. Yeah, whatever that is. Now I think cos 30 has actually a particular value which you're supposed to memorize at GCSE. So I'm hoping it's a whole number. We'll do that. All right. Anyway, so the point is that horizontally, the motion, it's not going to accelerate because there's no force acting on it horizontally. But vertically, it really is going to accelerate. Well, it's going to decelerate first. The vertical side of the story is the object's going to go up, it's going to reach a maximum height, and then it's going to go back down again. And we can so basically we're chopping up this story into two parts. We've got the vertical side of the story, and we've got the horizontal side of the story. Okay, so we've actually got the initial velocity in either case. Okay, so all right, so the vertical side of the story is u. So u vertical is u sine 30. I believe sine 30 is 0.5. Yeah. So u sine 30, well, u was 15. So that's just going to be 7.5 meters per second. Okay. Does that make sense? Yeah. Okay. So we've got the initial vertical velocity. So it's 15 meters per second. Now, and we know that the final velocity at the maximum height is going to equal to 0. And we also know that the acceleration is equal to 9.81 meters per second squared. That means we've got three variables, so we can use suvat to calculate any of the other ones. So we just need to identify which is the equation that we want to use. So v equals u plus at. We've got t. We want s. We want the height, don't we? So we want s. So s equals ut plus half at squared. I think that does it. No, I think we want s equals v. I think we want the fifth equation. So s equals vt. No, we don't want v. We don't want to use t because we're imagining we're going to calculate that. So we want v squared equals u squared plus 2as. I think that's the one that we want. Yeah. Okay, I'm just going to stop the video again there. We'll have to chop it into 3 or 4 bits.